So today I want to talk to you about rotation. A rotation is basically taking an object and turning it around in a circle from a specific point. So if you imagine that you had an object on the number 1 and you were turning that object around your circle like the hands of a clock. Now, to be able to do that, you need 3 things. You need a centre of rotation. So, for instance, the hands of your clock rotate around the very centre of the clock. So where your 2 hands meet, that's your centre of rotation. You also need to know the direction of your rotation, so whether it's clockwise or anti-clockwise. So clockwise is the direction that the hands of a clock travel. So starting at 12, going 1, 2, 3, 4, 5, 6, and that's clockwise. Anti-clockwise would be going in the opposite direction, so starting at 12 and going 11, 10, 9, 8, 7, 6, 5. And then you need the angle of rotation, so you need to know, okay, if you're travelling in a forwards direction, so in a clockwise direction, how far you need to travel in terms of rotation before you have to stop and put your object down. So I thought I'd give you a nice example of this. So I have drawn a shape for you, and I've decided that I'm going to give my centre of rotation the point -6, 3. So I'm going to select a point, and before I do anything I need to put my centre of rotation in place. So it's -6 and 3, which sits there, okay? And I've decided that my angle of rotation is going to be clockwise. So that means that my object is going to be travelling this way. Now, I haven't decided on an angle of rotation because I'm going to first show you what rotation looks like, and then I'll show you how to work it out, how far something's travelled afterwards. So what I'm going to do is I'm going to select my object and tell my computer that it's going to rotate around this point, but it's going clockwise, and I'm going to tell it that I want it to move freely. So let's put in a slider. I've done that. Okay, ready for this? So notice that as I increase my angle, my object is moving further and further around my circle or my clock face, so it looks like hands of a clock. Now, notice that if you start with a rotation of 0, your object is in exactly the same place, and if you do a full rotation, which is 360 degrees, because that's how many angles you have to travel around a clock, you would also end up back in the same place. So what I'm going to do is I'm going to move mine by 150 degrees. So my angle of rotation is going to be 150 degrees, but I'm going to show you how to calculate that, so we can check that I've got it right. Now, the trick is to draw a line between one of your points that you think you could recognise easily, okay, and your centre of rotation. Now what we're going to do is measure an angle of 150 degrees. So from here, I'm going to measure an angle clockwise of 150 degrees. So how you would do this in real life, oh, I want a donut, put it in the wrong place. So I want it from here, I want an angle with a given size, and I want that clockwise, and it's still there, I'm doing something wrong, hang on, let's sort that out. So what you would do is put your cross hatchings of your protractor on this point, your crosshairs, and then you would run your 0 up this line. Then you would measure 150 degrees and put a little dot. Then what we would do is just extend this line on your dot. And what that does is it tells you which line this specific point would sit on. Now what we need to do is measure the distance between this point and this point. So we're going to measure that somehow, where have I put it? There we go. So I'm going to measure the point between here and here, which is 6.32, and then I would measure 6.32 this side and put my dot. Notice that I've got a little dash here for saying that this is the image of the length E to D. So it's saying that they're identical, but this is the one that we're creating, and this is the original because it hasn't got a dash. Okay, now I would then measure, I would now do this again for another object. So I would measure the distance between here and here, and then I'd draw a line, measure 50, and that would allow me to do the same thing. However, if you've got a very nice rotation, so say for instance I just keep rotating this shape until it sits on a nice, until it snaps to the grid. So for instance, if I did, let's find, I think 180 might be the only one that's nice. Let's just check. Nope. Yeah, I think 180 is going to be the only one. Give me a second. Okay. Now, if I didn't have 50 degrees, if I had 180, the easiest way to do it would be to look at the pattern. So for instance, I know that this line and this line goes straight through these 2 points. So I would measure my 6.32 and then I would measure the rest of the distance to get to this one. Oh, that wasn't meant to happen. So let's put a label on that. So for instance, B would be exactly the same distance between B and D as here and here, so then I could label this as B by just measuring the extra distance I needed to travel. Then, because I know that this A is 1 up from B, I know that because everything is travelling round in a circle, it's going to be ahead of B in time, so it's going to be down this way. So that gives me my A image. Then I know that the relationship between D and, I'm guessing this is going to be C, is that I go across 2, back 2, and then down 1. So here, from D, I'm going to go forwards 2 and up 1 because it's the reverse image. And that would give me C. So in my next video, I'm actually going to construct one for you using an actual exam question.